Okay, this is chapter 7, lesson 10, and today we are going to be proving / forming trig identities. So, a few tricks and tips that I've got for you to deal with this stuff. Obviously, the main one, the absolute main one, is make sure you got those formulas written in front of you and you're not scrambling around to look for them. Be organised about that. Obviously, I'm leaving on these slides because I can't remember them off the top of my head, so have them in front of you. Also, the other one is cheat a little bit. Take the right hand side and tidy it up, or take the left hand side and tidy it up, see what it sort of would look like before you got to it. Now this question is a really good example of how that might be handy. Now I'm going to be doing most of my work on the left hand side, okay? Most of my work on the left hand side because the left hand side is the most messy, it's got the most threads that I can sort of pull at. Now looking at the right hand side, I've got 1/2 of sine of 2 theta, which is 1/2 of 2 sine theta cos theta, which is going to be sine theta cos theta. Now that there isn't immediately obvious that you've got 1/2 of the double angle formula, okay, but once you find that for you working on the left hand side, once you head towards that, if you can head towards that, then you've got the last 1-2 steps after it already done for you. Now looking at the left hand side, it's got 2, which doesn't really help us too much with this thing because I'm trying to head towards this. Remember, I'm trying to head towards this, not towards this. I'm not interested in heading towards that because that's got 2 theta and I want thetas. So it's got the 2, that doesn't really help. It's got the sine, it's got the cos, that doesn't really help, but cos of theta does already exist in there. Okay, so I'm expecting basically that this chunk here is going to produce sine of theta. Okay, so let's take a look, see if we can get it to do that. So we've got 2 sine of theta over 2 cos of theta over 2. I'm even going to just square bracket that and leave the cos on the outside because I know that I'm not going to touch that. Okay, I'm not going to be interested in touching that because I'm going to be using it as part of this and then heading towards the answer. So all I need to do is just get this to be sine of theta. Well, it does equal sine of theta. If you compare this, okay, this formula, 2 sine A cos A, to this, we've got the 2, that's fine. In this case that would be A and this would be A. Okay, so we have 2, we have sine of 2 of theta over 2 cos of alpha, cos of theta. Okay, this here, if you compare it against this here, okay, you can spot that this is going to come out. Now that is sine of theta cos of theta, as we expected. Okay, 2 times theta over 2 is going to produce theta. All right, but it doesn't quite give us that. We need to get that there, don't we? Okay, so what we're going to do is we're going to say, well, that there is identical to this. Okay, that step came from up here. It didn't come from my mind just now. It came from up here. So use these little right hand side steps, okay, and you can always cross them out later. And once you've got that, you've got 1/2 of sine of 2 theta. Once you've done that, you've got your answer. Bang, 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 get rid of those, okay, and the answer looks absolutely perfect. All right, moving on. We've got 1 plus cos of 4 theta is identical to 2 cos squared of 2 theta. Now, looking at cos squared of 2 theta, you might think that you could do a double angle thing on it. It would be absolutely pointless. It'd be an absolute nightmare to do that. It'd be really rubbish because you'd end up with sine, or you'd end up with powers of 4 and all sorts of stuff with it. Wouldn't be any point. You could be thinking that you might want to do like a 1 minus sine squared thing on it. Wouldn't be any point because it doesn't match up against the right hand side. Okay, so the left hand side, pardon me. So we're going to have a little look at what can happen with the left hand side first. So we've got 1 plus cos of 4 theta, okay, cos of 2 of 2 theta. Okay, that's true. 2 times 2 makes 4. But what that does is it opens up this row for me. Okay, gives me some options that I can use for it with A being 2 theta. So the one I'm going to use is that one there. It wouldn't make any sense for me to use one which introduced sine. So I'm going to have is 1 plus 2 cos squared of 2 theta minus 1. Okay, that's what that chunk there turns up into. Okay, and it's helpful to identify that A to use it throughout. 1 take away 1 is 0, and so you get 2 cos squared of 2 theta as expected. Okay, in that case, working a little bit of the right hand side wouldn't have probably made things much easier. Okay, it would have been very unlikely that working that right hand side you would have produced this. Okay, sometimes you just have to go left hand sided only. Alright, moving on. Prove this identity. So we've got tan of 2 theta equals 2 over cot theta minus tan theta, which is quite a nice looking identity really, isn't it? If you look at this as an identity versus this here, they must be identical. This and this must be absolutely identical, but it's not particularly obvious why. So working on that right hand side, I've got 2 over 1 over tan of theta minus tan of theta. Okay, so I know that that's going to be produced somehow. All right, so tan 2 theta. Well, tan 2 theta is equal to 2 tan of theta over 1 subtract tan squared of theta. All right, now we're going to compare this versus this, and then we're going to use this to get our very last step. We're going to compare this and this. Well, 2 tan theta over tan theta would be 2. 1 over tan theta would be 1 over tan theta. And we basically just divided every single term through by tan theta. So what I'm going to write is I'm going to write 2 tan theta over tan theta all over 1 over tan theta minus tan squared theta over tan theta. Okay, essentially I'm just dividing the numerator and the denominator by tan theta, which is a version of 1, isn't it? Okay. Tan theta's cancel, 2 over 1 over tan theta minus tan theta. That there is cot theta, isn't it? And we end up with 2 over cot theta minus tan theta. Okay, job done. I found the right hand side to be handy for me to know that I just divided through by tan. I wasn't going to do anything mad trying to manipulate it too much. Okay, so those are proofs of identities, not using any particular value for theta, not using kind of a compound angle formula and knowing an A or a B as a value in degrees or radians, just proving identities and manipulating a bit of algebra or trigonometric algebra. Your tasks, it looks a bit weird because you're only doing question 1, A, B, C, E, G and I extension. You can do more of 1 and a bit of 7, but the remaining questions on there call for you to use kind of values, like use 15 degrees, 30 degrees or pi over 3 or something like that, and that's going to be included within the next lesson. For this lesson though, you need to get a bit of practice of producing these identities. Okay, make sure that you take a picture of it, make sure that you mark it, pop it onto Google Classroom for me and get in touch if you're stuck on anything. Hopefully that helps. Cheers.